Now, monosubstitution just means that we've only added one electrophile. We've only substituted one electrophile for one hydrogen. So it was a monosubstitution. Right? Notice that it's the electrophile that's doing the substitution. So that's why we call it electrophilic aromatic substitution. So the electrophile is doing a substitution on the benzene ring. Right? In nucleophilic aromatic substitution, the nucleophile is doing the substitution on the benzene ring. If the nucleophile is reacting with the benzene ring, then the benzene ring must be an electrophile. Does that make sense? It's because we put the nitro groups on there. Yeah, it's because we put the nitro groups on there. So we'll work at it so you can see it. Withdrawing, that's right. Therefore, making the benzene ring to be electron deficient. There it is. That's right. Yeah. So this is you seem like you're shocked. All right. So there it is. So the substitution, right? So now, once we have the first electrophile on there, this electrophile can be different things. This is just generic, right? It can be different things. So now, this is going to have a directing effect, right? This electrophile is going to have a directing effect when we add another electrophile on here. So this in itself is going to have a directing effect. Just because it's generic, we don't know what the directing effect is. But of course we can have it ortho, para, or meta, right? We'll get into how you determine. So what happens is that now if we have another benzene ring that already has been substituted with an electrophile, and yet again we do another, we're trying to add another electrophile on here, we can get one of three possibilities. Actually, we might have two, but we can have any of these possibilities. We'll call this E1 and we'll call this E2. All right. Okay, so now depending on the directing effect of this group, right? If this group was an activator, all right, we'll get into it. So if let's see. So if E1 is an activator, E1 is an activator, it's going to direct E2 to the ortho or the para position, right? Now, so in this case here, this group is here, this is ortho, this is para to it. So E2 can be here, or it can be here. And this is the para product, and this is the ortho. Now, what does it mean to be an activator? It just means that, okay, think about this. Let's go back here. We have a nucleophile and an electrophile. If we want to activate this benzene ring, we must make it more nucleophilic. All right, because that's how the reaction is occurring, right?
So an electron donating group. Perfect.
Because we want it to be more electron rich, so we want an electron donating group on there. So this E1 would have been an electron donating group for this one, right? So a group that donates electron density or lone pairs. So it's a little bit different depending on the group you're talking about. So they're going to be activating this ring, meaning that they're making it more nucleophilic, meaning that they're making the reaction want to occur, right? So they're going to be directing E2, meaning that the other electrophile we want to add onto the benzene ring, either to the ortho or the para position. Usually we form more para than the ortho. So it usually happens. Perfect. And if E2 was a deactivator, then, I'm sorry, if E1 was a deactivator, I put E2 here, E1, okay. Perfect, end up in meta. Right, and deactivator meaning it's going to pull away electron density from that benzene ring. That's right. So now let's get into what are my electrophiles. So So we're going to figure out what are our electrophiles here. So we're going to use a little mnemonic for this. The mnemonic is Hans. Have you heard of this mnemonic before? Okay, that's okay. Alright, so let's start off with the name first. Alright, I gotta get the name of the reaction first. So the first one is going to be halogenation, right? Acylation, alkylation, nitration. Perfect. Yeah, so why don't we tackle them at the same time? So that's the generic E is going to be coming from any of these reactions. So now let's look at what the reagents is going to be. What are the reagents going to be for these reactions? Alright, did you want to check your notes? Okay, you can go ahead, check your notes. We're mainly going to be doing BR2 and FeBr3, Cl2, AlCl3, and some Lewis acid. Mainly you're going to see bromination and chlorination. Then for the acylation, yep, that's right. And we can connect these. Let's see, do we have any more space here? Okay, we do got space here. Okay. These guys are going to be Friedel. Craft. Okay. So for the acylation, we're going to be using an R group, some kind of halogen. I could put an X on here. Some kind of halogen, and some kind of Lewis acid. Alkylation. Yeah, some kind of carbon chain. Some kind of halogen, some kind of Lewis acid. It can be different. If we had bromine here, we could have FeBr3, right? So depending on what we have, right? Yeah. You can have an RBR here, and you can have FeBr, right? It's just the main thing is we want to attach this. We would get into it a little bit, so we'll look at the different reactions and. We'll go. We can get it as detailed as you want. I'm trying to give you a better overview, and we'll go over the reaction pattern, and I'll list it off for you, so you will know exactly what happens. Cool. So now, and then for the nitration, we're going to be using HNO3, H2SO4. And then for the sulfonation, I believe it was SO. You can use SO3 and 2SO4. And sometimes you can just use H2SO4, or sometimes they might just put fuming sulfuric acid. There's a variety of ways you might see this. Like now, we need to know what our electrophile is going to be. So each of these reactions is going to create an electrophile. You have your notes on this, right? Sort of. Yeah, we might need it here so we can kind of verify these electrophiles. Some of them is clear, some of them are not. It depends on how your professor wants them to be shown. Some professors say that this is acceptable, PR+. Some professors say it's not acceptable. Some professors want to see, they want to see this whole entire actually, this would be positive. This would be negative. Something like this. Do you remember something like this? Okay. We'll have to look through your notes to verify. If you don't, it's okay. For this one, this should be fine. This should be fine. Okay, it's okay. So I'm just listing out how some of the electrophiles will look. Let's see. Alright, so it's reacting, and we're going to remove this positive. It's not supposed to be here. It's supposed to be here, right? Or you might see it a little bit different. If this one here, we get a resonance, positive charge here. Alright, this one is going to be R+. This is R group. And, oh, I put this in the wrong section. It's supposed to be S here. And then for this one, it's going to be nitronium. Okay, so those are going to be the electrophiles that we're going to be using. Alright, so we're going to have